What if the key to revolutionizing renewable energy usage lies in our ability to store energy? Can advancements in energy storage make power grids more efficient and promote sustainable energy practices? These questions lead us to the heart of the energy storage conundrum. Currently, energy storage is a mixed bag. On one hand, we have hydroelectric dams, the dominant form of bulk energy storage, and on the other hand, we are seeing the rise of green hydrogen, an economical means of long-term renewable energy storage. But there's a catch. Energy storage is still struggling to keep pace with the growth of renewable energy. The intermittent nature of sources like wind and solar power demands a reliable and efficient energy storage system. The need for high-density energy storage devices is more pressing than ever. These devices could bridge the gap between energy production and demand, making power grids more efficient and fostering sustainable energy practices. The solution to this might be found in a relatively unknown equation, the McGinty Equation. The McGinty Equation, or MEQ, may not be familiar to many, but it could hold the key to our energy storage problems. At its core, the McGinty Equation is a complex mathematical model that combines several aspects of quantum physics and gravity. Let's think of it as a mathematical recipe for understanding and predicting how energy behaves under various conditions. First, let's talk about the free quantum field theory, denoted by P=Ft(xt) in the equation. This part represents the solutions we get when we apply the principles of quantum physics to a field. Think of it like a playground for particles. It helps us understand the behavior of particles at the quantum level, where things get a bit, well, weird. Next up, we have the fractal potential term represented as P's fractal xt dmqs. This term brings in the concept of fractals, which are structures that exhibit self-similarity across different scales. Imagine a snowflake or a fern leaf, where each part is a smaller version of the whole. In the context of the MEQ, this term helps us account for patterns in energy behavior that repeat at different scales. Finally, we have the perturbative effects of gravity on the quantum field, denoted by gravity (g). This term represents how gravity, the force that keeps us grounded, affects energy at the quantum level. It's a bit like considering how a strong wind would affect a game of ping pong. Each of these components plays a vital role in the overall equation. Together, they provide a comprehensive model that allows us to predict and understand energy behavior under a wide range of conditions. Now that we understand the MEQ, let's delve into how we can use it to develop high-density energy storage devices. So, how can the McGinty equation be used to revolutionize energy storage? Let's delve into that. The McGinty equation, or MEQ, is a mathematical framework that opens up a new world of possibilities for energy storage. It's a formula that, when applied to the design of energy storage devices, could potentially lead to the creation of high-density energy storage solutions. This is where the magic happens. The inclusion of the fractal potential term VYT in the MEQ, which has a self-similar fractal structure, offers a fresh perspective on energy storage design. Essentially, it allows us to manipulate energy storage on a quantum level, creating devices that have the potential to store vast amounts of energy in a small space. But what does this mean for renewable energy usage? Well, it could be a game changer. High-density energy storage devices based on the principles of the MEQ could make power grids more efficient by storing excess energy produced from renewable sources for later use. This stored energy could then be released during periods of high demand or when renewable energy production is low, such as during the night for solar power. This could lead to a significant reduction in the reliance on conventional energy sources, promoting more sustainable energy practices. The growth of renewable energy has increased interest in storing power from intermittent sources like solar and wind power. The MEQ's potential to revolutionize energy storage could be a critical step in meeting this demand. Moreover, off-grid electrical use, which has expanded in the 21st century with portable devices and solar panels becoming more common, could greatly benefit from the development of these high-density energy storage devices. So the McGinty equation isn't just a complex formula to be left in the hands of quantum physicists. It's a powerful tool that could potentially revolutionize the way we store and use energy, making renewable energy a more viable and dependable option for our power needs. This isn't just about improving energy storage, it's about reshaping our approach to renewable energy. The McGinty Equation and energy storage, an unexpected pair, could be the game changer in renewable energy usage. Energy storage, the simple concept of capturing and storing energy for later use, is a cornerstone of modern power grids. It allows us to balance energy production with demand, a key challenge in the renewable energy sector. But how does the McGinty Equation fit into this picture? The McGinty Equation, or the MEQ, is a mathematical model in quantum field theory. It combines free quantum field theory with a fractal structure to describe the behavior of quantum systems. The MEQ has the unique ability to account for the effects of gravity on quantum fields, a feature that sets it apart from other equations in the field. But why does this matter for energy storage? The fractal structure of the MEQ, described by constant parameters, allows us to model complex systems with self-similar patterns. This could provide a deeper understanding of energy flow and storage mechanisms, paving the way for the development of high-density energy storage devices. These devices could revolutionize the way we store and use renewable energy. Imagine a world where solar and wind energy can be stored efficiently and used on demand, without reliance on weather conditions. This would make our power grids more efficient, reduce our dependence on fossil fuels, and promote sustainable energy practices. The potential impact of combining the McGinty equation with energy storage is immense. It could transform the renewable energy sector, reduce our carbon footprint, and help us move towards a more sustainable future. Remember, the MEQ is more than just an equation. It's a tool that could help us unlock the full potential of renewable energy, making it more accessible and efficient than ever before. The future of renewable energy may very well be written in the language of the McGinty equation,